Hey everyone, in this video we'll learn how to find the domain of a composite function. So let's write down the functions f of x and g of x. So f of x, let's say, is 2 over x minus 1, and g of x is 4 over x minus 2. And we want to find the domain of f of g of x. Okay, so first, let's go ahead and take a look at the domain of f of x. So we could tell f of x is a rational function, and for rational functions, this rational function right here, 2 over x minus 1, the domain is any x value as long as it doesn't make the denominator 0. Because if this fraction becomes 2 divided by 0, then that's a really big problem because we can't divide by 0 in mathematics. So as long as the denominator right here, x minus 1, as long as x minus 1 is not 0, x can be any other number. So let's go ahead and solve for x in this little mini equation. So let's add 1 to both sides. And we have x cannot equal 1. Okay, so we know x can be any number as long as it doesn't equal 1. So to write the domain in interval notation, that would just be from negative infinity to 1, and then union 1 to positive infinity. So that would be the domain of f of x in interval notation, every number except 1. Great, so now let's try to find the domain of g of x. So same thing, this is also a rational function, as long as x minus 2 does not equal 0. So let's go ahead and do that. X minus 2 does not equal 0. And what we'll do is add 2 to both sides. We have x does not equal 2. So x can be any number as long as it's not 2. It can be any number besides 2, any real number. So let's go ahead and just write an interval notation. It would be from negative infinity to 2, parentheses, union 2 to infinity, parentheses. And that's the domain of g of x right there. Great, so we found the domain of f of x, we found the domain of g of x. What about f of g of x? Well, f of g of x, let's actually try to find its formula. Let's write the formula for this composite function, f of g of x. So what we'll do, we have f of g of x. We know up here, f of x equals 2 over x minus 1. So that means f of g of x equals 2 over g of x minus 1. And what is g of x? G of x is 4 over x minus 2. So let's scroll down a little bit. And we're going to say this equals 2 over, and g of x right here, we're going to replace with 4 over x minus 2. So let's write that down. 4 over x minus 2, and then minus 1. So we replace g of x with 4 over x minus 2. There we go. So this is the formula for our composite function, f of g of x. And as you could see, this is also a rational function. We have x in the denominator right here. And what we're going to do is we're actually going to do two things. We're going to look at the denominator, and we are going to set the denominator not equal to 0, similar to what we did for f of x and g of x. So we are going to set 4 over x minus 2 minus 1 not equal to 0. And keep in mind, be careful, there's another denominator right here. We have this other denominator within the denominator, x minus 2. So this denominator, x minus 2, it can't equal 0 either, because we would also be dividing by 0. So let's set up another equation. X minus 2 cannot equal 0. So now we've set up these two equations, and let's go ahead and solve for x in each of them. Let's do the easy one first on the right. Over here, it's just a simple one-step equation. We can just add 2 to both sides, and we'll have solved for x. X cannot equal 2. Good. So we have one part so far, x can't be 2. And now we'll go ahead and solve the equation on the left-hand side. So let's scroll down. And what we're going to do is we're going to add both sides by 1 to cancel this minus 1 out. We're left with 4 over x minus 2 cannot equal 1. 0 plus 1 is 1. And now here, we're just going to multiply both sides by x minus 2. That should cancel that out. And we have 4 cannot equal, and what's 1 times x minus 2? So 1 times any number is just that number. So 1 times x minus 2 is simply just x minus 2. And let's go ahead and solve this. We'll add 2 to both sides. And we've isolated x. We have x cannot equal 4 plus 2, which is 6. Good. So x can't equal 6, and x can't equal 2. We have x can't equal 6, and x can't equal 2. So that means our original composite function up here, f of g of x, the domain for this one is every number except 6 and 2. So how that would be written, it would go from negative infinity all the way to 2, but not including 2, so we'll use the parentheses, union every number between 2 to 6, parentheses, and then another union, every number from 6 to infinity, parentheses. And that is the domain of f of g of x. And that's how we find it for this composite function. Now let's do something a little different. Let me go ahead and erase this. Let's just go ahead and erase some of this. Let's try to find the domain for g of f of x. So the domain for g of f of x, so it's the same process. We're going to go ahead and find the formula for g of f of x. We know up here that g of x equals 4 over x minus 2. So that means g of f of x, that equals 4 over f of x minus 2. All we did was substitute x for f of x. And now what is f of x? F of x over here is 2 over x minus 1. So we're going to replace f of x with 2 over x minus 1. So 4 over 2 over x minus 1 minus 2. All we did was replace f of x with 2 over x minus 1. Good. And that is our composite function. That is g of f of x. That's its formula, in formula form. So now what we're going to do is we're going to find the domain of this function based on its formula. And we know that the entire denominator right here, it cannot equal 0, so 2 over x minus 1 minus 2 cannot equal 0. And we also know the small denominator over here, x minus 1, also cannot equal 0. So x minus 1 also cannot equal 0. So let's go ahead and solve both of these for x. We can solve the easy one first on the right. So we'll add 1 to both sides. We have x cannot equal 1. Good. So we have that. Now we're going to solve this one right here on the left. We're going to solve for x. So first step we can do is just add 2 to both sides. We have 2 over x minus 1 cannot equal 0 plus 2, which is 2. And we'll keep going to isolate this x. We'll go ahead and multiply both sides by x minus 1. That will cancel that out. And we're left with 2 cannot equal. What's 2 times x minus 1? Well, with this parentheses, we're going to go ahead and distribute this 2. So 2 times x times or plus 2 times negative 1. So 2 times x is 2x, and 2 times negative 1 is negative 2. And then we'll keep going. We'll add 2 to both sides. And then right here we have 2x, which I'll just write over here. It cannot equal, and then over here, 2 plus 2, that is just 4. So 2x cannot equal 4. We divide both sides by 2. X cannot equal 2. There we go. So we have x cannot equal 2, and x cannot equal 1. So the domain for g of f of x, the domain for this, is every number except 1 and 2. And how we write that in interval notation, it goes from negative infinity to 1. And then every number between 1 and 2. And then every number after 2. So this is the domain of g of f of x. It is every real number except 1 and 2. So that's how we find the domain for composite functions. I hope this video helps, and if you have any questions at all, please leave them down in the comments below, and thank you for watching.